For today's question, let's look at this right angle triangle ABC with right angle at A, and the length of AB is 6, the length of AC is 8. Now, given that P is a point on BC and Q is a point on AC, you'll also find the minimum value of AP plus PQ. Please have a good try before you look at the answer.
Pause the video now if you wish to solve it. Keep watching the video once ready.
So one very interesting argument for this question is that from A, you want to choose a point P on BC. And from the point P, you want to choose a point Q on AC. So it is obviously that AP minimum is when AP perpendicular to BC. So in that case, AP is minimum. And from this point P, PQ is minimum if PQ is perpendicular to AC. So it's just like our life. We are at the point A, then we go to the next stage. We need to make a choice in our next stage of life. Out of all the choice, we know that P is the best. So from this stage, we go to the next stage at this P. And from this P, we go and see all the possible choices that we have, and we know that PQ is the best. So overall, we say that AP plus PQ in this manner will be the best. Do you agree? Let's look at this simple geometry question. So if this is the case, then we are able to calculate what is AP. Now note that AB equals to 6 and AC equals to 8, then BC is equal to 10 from Pythagoras theorem. Then if we consider the area of triangle ABC, then it can be equal to half 6 and 8, or it also can be half 10 times AP, 10 times AP, if this is perpendicular. So AP in this case is equals to 4.8. And we need to find out what is the value for PQ. Since this is 6, BP will be equal to 6 squared over 10. That is 3.6. Because of similarity, PC equals to 8 squared over 10, and that is equal to 6.4. So we know that PQ over 6 will equals to 6.4 over 10. So PQ over 6 is equal to 6.4 over 10. And therefore, PQ is equals to 3.84. So in that case, we have AP plus PQ will equals to 4.8 plus 3.84, and this is equals to 8.64. Let us look at this question again and see whether it makes sense to us. We'll also find the minimum value of AP plus PQ, where P can be any point on BC and Q can be any point of AC. And we find out that AP is the best for all the P on BC. With this P, this PQ is the best for all the variable Q. However, the sum is equal to 8.64. It doesn't make sense because I can actually choose P to be as close as C. Then AP plus PQ will be very close to 8. But this value is a lot more than 8, and therefore it cannot be the minimum value of AP plus PQ. right? So there must be something wrong here. The best for the AP plus the best of PQ, it doesn't mean that the best for overall. And this is one example. Okay, so how are we going to do this? Well, we can use two different ways, and today we discuss one of them. So to get the answer for this, we can just simply use the idea of reflection. If you enjoyed this video, please like, comment, and subscribe. We reflect ABC on the line BC, and the diagram that we have will be something like this. Where this is A prime. Then we see that A prime C also equals to 8. If we join A to A prime C in such a way that this is a 90 degree, this is 90 degree, then we claim that this is the point P and this is a point P prime because the corresponding P is here. And we claim that this will be the minimum. Why is it so? It's because for any point that we have just now, like this, so the corresponding point will be reflected somewhere here that will make a 90 degree. We can compare the sum of these two red lines and this black line. And we'll see that because this is perpendicular, so they are parallel. And this part here, which is 90 degree, will be of the same length. This portion is definitely less than the hypotenuse. So this applies to any point P on the BC. So now we claim that this APQ prime will be the minimum. So this is one observation. The second observation that we are going to make is that if we extend QP, then it actually will go to A prime. If we extend this, it will actually go to A prime. In order to get AQ prime, we just need to find out what is A prime Q. So what we know here is that AP plus PQ will be always greater than or equals to AQ prime. And this AQ prime will equal to A prime Q in this diagram. In order to get that, we first try to find out what is AA prime. We join AA prime because these two are of the same length, 6, and these two are of the same degree, say alpha, then it must be a 90 degree here. From the original triangle ABC, we know that the tangent alpha is equals to, the tangent alpha equals to 8 over 6, that is 4 over 3. And this means that sine alpha will equals to 4 over 5. So AA prime will be equals to double of AD. AD itself equals to 6 sine alpha. And the sine alpha is 4 over 5, 48 over 5. We need to find out what is A prime Q. In order to get A prime Q, we look at this again. This is alpha 90 degree, and therefore this is alpha again. A prime Q will equals to AA prime sine alpha again. So this will equal to 48 over 5 times 4 over 5. And we can times 4 over 4 so that this denominator becomes 100, and this equals to 48 times 16 over 100, and this is 7.68. So now we know that AP plus PQ must be at least 7.68. The equality holds if and only if P is somewhere here. This is one way to get the answer. Now maybe we discuss a little bit more for another answer using geometry. There will be another answer using algebra and inequality, which I'll leave it to the audience. Call this is theta, This is theta. So the tangent theta from the triangle ABC, tangent theta equals to 6 over 8. That is 3 over 4. And what we want to find is only A prime Q. A prime Q over A prime C equals to sine 2 theta. And A prime C equals to 8. So this is 8 sine 2 theta. Now let us recall the formula for sine 2 theta in tangent theta. Sine 2 theta equals to 2 sine cos. And since this is divided by 1, we can just divide by cos square plus sine square. And now we divide both numerator and denominator by cosine square. When you divide by cosine square, this is 1 and this is tangent square. When divided by cosine square, one cosine cancel off and there's another sine over cosine, that is tangent. So with this, we just prove the identity sine 2 theta equals to 2 tangent theta over 1 plus tangent square. Giving tangent equals to 3 over 4. This is 2 of 3 over 4 and 1 plus 3 over 4 square. Now we can multiply the numerator and denominator by 4 square. So 4 square cancel with 4, that is 24. And for this, 4 square plus 3 square, that is 25. So with this, sine 2 theta equals to 24 over 25. So this is 8, 24 over 25. We multiply with a 4 over 4, so that this is equals to 100. And again, this is 32 times 24. And this is again 7.68. So this is another method using trigonometry. For the algebraic method, I'll just give a hint to consider some inequality. The diagram is a bit ugly. Let me draw it here with coordinates. So this is A with the coordinate 0, 0, and B with the coordinate 0, 6, and C with the coordinate 8, 0. So we join B and C. Now this is a point P, X, Y. We do not know where is the P, but we sure that no matter what is this P, this Q has to be 90 degrees so that it is minimum. So our target is to find the minimum of AP plus AQ. AP will be square root of X squared plus Y squared. And PQ will be just equals to Y. We transform this geometry question to algebraic question is that to find the minimum of this expression if P is on this line, and this line is X over 8 plus Y over 6 equals 1, where X and Y has to be greater than or equals to 0. So we transform this geometry question into this algebra question. So you may just try to get the minimum value based on the condition here. Of course, the answer must be equal to 7.68. That's all for today's discussion. I'll see you again next time. Bye-bye. Oh yeah, please do not try to use the Lagrange multiplier on this. It is very messy. Bye-bye.